Welcome back. Today on the bench I've got a bit of a small amplifier, small audio amplifier prototype. So it's Class A single-ended, using these output transformers that came out of this thing here, which is a German low opto radiogram, very small radiogram. So it would have had a record player here, and this is the chassis that goes in it. That's the radio section, and the audio amplifier was here. Now it used a odd valve that I've not come across before, which is an ELL80, which is two pentodes in one bottle. Basically the original idea was that the chap whose this is wanted me just to get it going. And after mucking about a bit, I got it going. Well, I got the audio amplifier going, but the problem was that the ELL80 was very weak. It was knackered. So I said, oh well, no problem, I'll just knock up a simple single-ended amplifier, stereo amplifier, because these output transformers looked, they don't look too bad. They're quite of a decent size and what have you. And weeks later, put a hell of a lot of work into it and got really nowhere. So the main problem, I had a few problems. Originally this used a selenium rectifier, so this mains transformer has got far too much voltage for what we want. So it's something like 288 volts AC, which when rectified gives us 380 volts AC, which is about 150 volts too much. Hence that's why I've taken all the laminations off, and I'm just going to pull a load of the HT secondary off. So that was one problem. As I mentioned, the other problem was that the EL80 was knackered, and so I thought, right, well, what valves have I got that, cheap and cheerful? I had a look. I got a few ECL82s and things of that nature. In the end I found a couple of PCL86s, which is what we've got underneath there. So basically I knocked up this, I hope you can see that, which is a pretty simple single-ended amplifier. As far as I know, the PCL86 and the ECL86, it's got more or less the same sort of pentode beam tetrode as the EL84, but with less power output, and an ECC83. So when trying to get all this working, the problem I found was, first off, this bloody thing oscillated straight out of the gate, as it were. The damn thing oscillated. As soon as I connected this capacitor here to the grid, to the control grid of the pentode, it oscillated at about 25 kilohertz. After farting about and looking at a few PCL, ECL amplifier schematics, I noticed that there was something like a 3 picofarads going from the anode of the pentode to the control grid. Yeah, it didn't really work. It sort of worked, but didn't. In the end, I ended up putting a 1N capacitor across the primary of this output transformer. That stopped the oscillations. And then the last few days I've just been farting about trying to get the conditions right, because the problem is with these Class A single-ended amplifiers, and I have designed one before, is that you've only got a very small amount of wattage, 3 watts or 5 watts at the most, depending on the output transformer. And like with all amplifiers, the output transformer really dictates the amplifier, how the amplifier is built. So you've only got a very small amount of headroom. So it's quite easy it's actually quite easy to get like 1 watt out of it or something like that. But trying to squeeze those extra 2 watts out is quite problematic. So yesterday I messed about and find my notes. I actually kept notes this time. What I did, I got a variable resistor here, and so I changed the load, kept changing the load, left the input the same, and saw basically how much power I was getting out to try and find the right load. The problem I thought I had originally with these bloody output transformers is that they have a very high turns ratio, 44 well, it's actually more like 42, 43 to 1, meaning that we can't really just use an 8 ohm load. That's what I thought. So anyway, I did this experiment yesterday. I started from about 2 ohms and went all the way up to 7, well, nearly 8 ohms, and just to try and find out where the THD was about the best and where the power output was about the best. In the end I found that about 5 to 7.7 ohms on the secondary was about right. But then the problem I got is that this is a very sensitive amplifier. These PCL, ECL 86 is designed for like these radiograms. So the triode is it's basically an ECC 83 with a gain of 100. Well, if we want to put about 1 volt in, which is like your modern day line level, so what, you know, you're talking like iPhone MP3 player, that is far too much gain, way too much gain. These things are, you know, built for amplifying a very, like either a radio, the very small voltage you get out of a radio, or the very small voltage you get out of a ceramic pickup. So this valve isn't really what we want. If I was to build this and spend more time on it, which I'm a bit loath to do, I would use EL84s and something like ECC 82. That would be a lot better, but we have what we have, so we have to make some compromises. So instead of having a 220k anode resistor on the triode, I've got a 47k, which knocks the gain down a hell of a lot. The other thing I'm doing is knocking down the HT that the anode sees to about 200 volts. Could probably knock that down further. The other thing I'm probably going to have to do is to use some sort of voltage divider to cut the gain going into it, because at the moment it's clipping at about it's clipping at about 300 millivolts, and that's with the feed, and basically I'm chucking loads of feedback at this. All of that gain I'm wasting on feedback. I'm yet to measure that. So basically, to find the feedback, what I did was to just use a 10k variable pot and then just adjust it until it started to go unstable, and then just knock it back a bit. So as it is, like, it works okay. The frequency response is really good. It's good from about 50 Hertz to 20 kilohertz. In fact, well, let's show you. Yeah, the heaters are on. I've got, ooh shit, I forgot it's connected to a bloody speaker. Alright, well, let's try again. Heater's on. Go. Adjust the scope. Right, where are we now? We're less than 100 volts, no, about 150 volts. Uh, 250 volts. HD. Got a 1 kilohertz sine wave going in. AC, we've got about 1 volt coming out. and pretty decent total harmonic distortion, less than 1%, 0.1%. Let's just crank the amplitude up a bit. Amplitude 0.2. So it's gone up to 0.5%. And we've got 1.986, which is, I'm on my... Right, so I've just popped in 3 volts there, which is what we're getting now. I've just knocked the input up to 0.3, so we're getting a gain of what? 0.3 to 3 volts. It's a gain of 10, isn't it? So, it's just... don't know what's going off with my bloody scope. Right, so there's our output. That's with 0.3 volts going in. So look at the distortion, 1.7. Let's see if we can put a bit more in. Amplitude 0.4. Right, what have we done there? Amplitude 0.4. Right, as you see, we're clipping there now on the bottom and the top. That's 3.5 volts. Sorry I messed out, so we want amplitude 0.3 volts. So that's about as much as we're going to get out of it, which is 1.8 watts. So not a lot. I have messed about with this amplifier trying to get more out of it, but I can't see how we can. So here's the load line to drew, various load lines. So this is our load line for 8K here, which is what I thought it would have with a 4 ohm load, 4 ohm, you know, speaker. And obviously that isn't the finished load line, because like we've got a reactive load on the anode of the pentode output valve. Basically our load line can go beyond our HT. There I've got it at 275, which is what I thought I needed. So basically with a class A, what you do, you draw your load line, so using the same sort of mass as before for a triode, common, gain stage. So you do your HT 375 in this case divided by 8K. That's your point over here, and then obviously we go to 0 when we're at full HT, and then we swing that load line up to find a bias point. Because the voltage on the anode never changes, a bias point has to be here. It can't be up here. It has to be along basically a vertical line. And I've farted about with this, changing the cathode resistor on the pentode, but it seems to be happier about here at about 6 volts, which is near maximum anode dissipation, which I think is, what actually have we got there? Because I've changed it that many bloody times. A moment. Right, we've got 5.2 at the moment, but that's with a signal going in, so it's probably a little bit more. Yeah, so 5.2, which is somewhere here. Now then, let's just make, where are we? 5.2 divided by 150, right, 0.34. This is what I find frustrating with when you're drawing load lines and what have you, because what you actually get on the circuit when it's working isn't what you compute. So here look, there's about 5 volts there, so we should be getting 50 volts anode current. We ain't. We aren't indeed. We're getting 34 plus a bit of grid 2, so maybe 40 volts cathode current. Yeah, well that's what we just measured, isn't it? 34 cathode current. Right, so our anode dissipation is about 30, which is what I computed here, but we're actually up here. I don't know. Yeah, like I say, a lot of the times you write all these sums and what have you, and when you actually build the bloody circuit it's a lot different. Anyway, so that looks like what we're going to get out of it is 1.8 watts. That's the best we're going to do. However, we've got 1.8% total harmonic distortion. Sorry about the trace on the scope, it's not brilliant. Right, let's just do a quick sort of frequency demonstration. Frequency 100 Hertz. No, not frequency 100. I've got a bit of clipping down the bottom there, but you can see the amplitude is about the same. Alright. Let's just knock the frequency up. Frequency. So it's not brilliant, is it? So as you can see, the amplitude is about the same. Knock it up to 20. Frequency. And as you can see, we're starting to get some horrible clipping there. Let's knock the amplitude down a bit. That's better. But yeah, the frequency response is alright. Well, how does she sound? Well, let's go and have a look. Doesn't sound too bad. Bass isn't brilliant though. Mind you, this is just a crap test speaker, so we've got quite a bit of hum there, but we've got a great long lead going to the amplifier in the other room. It's quiet hum wise, but it is a really high pitched hum. Let's go and have a look. Right, as I suspected, with a right, this bloody scope isn't brilliant. I suspected it's oscillating with a speaker load. But you can see it better now the sun's gone in. Right, what are we there? That's 200 microseconds. Oh, God blimey. Whatever, it's oscillating. It told us here actually. 22 kilohertz again, look. But we can do something about that. We can stick a Zabel network on the secondary to kill that. Right, let's have a go at that while we're at it. Well, there's a Zabel there. 1 microfarad. One, whatever. Let's just call it 8 ohm resistor. It's reduced it, but it's still there. The layout isn't brilliant, which could be causing some of the oscillation, but all our connections are really good. We've got grid stoppers, everything's really close, the wires aren't that long. It's a bloody problem. Yeah, oscillation, right. Well, we've got to sort this out before we can build the amplifier. Let me just have a play. Okay, I just took a 1N capacitor off, and I've just got a 390 picofarad silver mica. Anyway, took that 1N off, and look what we've got. 70 kilohertz, so the frequency's gone up. Right, so without giving myself a shock, because there's 150 volts on there, it shouldn't be too bad if we get about, oh fuck, how am I going to get that in there now, you peanut? Right, it was easy when there was no high voltage there. Couldn't really, it's a bit hard to film this watching out for high voltage. See there, look, frequency's gone down. Okay, well let's try a bigger capacitor. Right, well that 47 mic across the primary of the output transformer, that works. Oh, sure I can still hear something, I don't know if that's in my head though or what. Right, I can't see anything. Scope isn't the best, but it'll do for now. Right, the bass response is still not brilliant, so I'm going to tack in a bigger capacitor across the triode cathode. One moment. Oh, that's better. Nice song to what do you call it? Audition the bass. So that works. I've just bunged in a 470 mic. And the other thing I can do is to up the screen grid capacitor decoupling. Right, well, I don't know, as I could tell the difference there. It's a bit mad really. It's only a 250 volt cap. I think I don't know, probably just increase the cathode capacitor. Sorry, my brain's not working. Anyway, that should give you something to go up at. Sorry, not been up on the uploading videos recently. It's a bit chaotic life-wise, blah blah blah. So right, I shall probably piss about with this circuit for another few days, although I hope not, because I really want to get it done, get the job done, so I can get back on this 6146 amplifier. So right, anyway, try and get the bugger done, try and get it built properly and not in the prototype stage, because that's a bit mad. Hope you're all alright out there and keeping well. Take care of yourselves. Ta-da for now.